So decimal to hexa conversion, hexadecimal conversion. So this is the given example 3509. 3509 is the given decimal value, and then we need to convert into hexadecimal number. So this is the integer part. So we need to do the successive division with the base value. So here base value is the 16. So 3509 divided by 16, its quotient is 219 and remainder is 5. So the remainder is, take it as a first coefficient, and then quotient is again divided by the base value, that is 16. 219 divided by 16. Now the quotient is 13, remainder is 11. So 11 will be the next coefficient. So here, so 11 means, so we don't write as a 11. So what I told, hexadecimal means it contains 0 to 9 only numbers. Then after that, so the 10, 11, 12, 13, 14, 15 are, it represent as a alphabets. So 10 is equivalent to A. When the 11, that is B. Like so here the remainder is 11. So that's why we mention here B. Got it? Okay. Next. So the quotient is 13. So 13 divided by 16. So here the quotient is 0 and the remainder is 13, and this is 13 value is equal to D is the its equivalent value. That is, so we don't write as a 13 in the hexadecimal. So its equivalent value is D. So that's why he mentioned here D. Okay. So DB5 is the equivalent of this decimal value 3509. Its equivalent hexadecimal value is D5, so DB5. Okay. So next in the fractional part. So fractional part, so what I told, so successive multiplication with the base value. So here base value is the 16. So 0.12890062 into 16. So 2.0625. Here integer will be take it as a coefficient, and the fractional part is again multiply with the base value, that is 16. So 0.0625 into 16. Then we will get, so 1.0. So 1 is the integer value, so that will take it as a next coefficient. So here fractional part is 0. So we will stop here. So because of 0 value. So its equivalent hexadecimal value is 0.21. 0.21 is the its equivalent decimal value. Okay. So far we discussed decimal to any base conversion. Now, so any base to decimal conversion. So like binary to decimal, or octal to decimal, hexadecimal to decimal conversion. So any base to decimal conversion. So we know the base value, that is, so which base to we are going to convert, we have to use this that base value. So if you are doing binary to decimal now, here we need to do 2 power, or octal to decimal na 8 power, or hexadecimal to decimal na so 16 power 0, 16 power 1, like that. So that is decimal number equal to, so in the position values, each bit position values. So the formula is given, and this is the formal notation. So here is any base, what I told here, this now we are discussing the any base to decimal. So we were discussed only binary, octal, hexadecimal, decimal value. These 4 number system only we discussed. So what any base to, apart from that, so any base, like here base is 5 is given, or base also 3. If you are giving 3 na, so from 3 to decimal number conversion. So how to convert the decimal, or 9 to base 9. So if whatever the base value, so its base value if 5 na, so here the numbers are within this number. This base value is 5 means 0 to 4. So it contains only 0 to 4 values only. That numbers only here having. That is 0, 1, 2, 3, 4. So totally 5 numbers. So that's why it's called base 5. So like any base. So for example, base 7 means so 0 to 6. Base 9 means 0 to 8. Likewise. So apart from what we discussed so far, standard, the binary, octal, hexadecimal, apart from this decimal value. So like this, any base can also ask in the exam. So if we ask like that means, so we have to follow this formula only. So what we do in the previous, like that only. So this is the 1, 2, 3 into, sorry, 0.42. So here the base value is 5. So take it, this is the fractional part. So here, so 0, 1, 2. So 0, 1, 2. That is base power, that is 5 power 0, 5 power 1, 5 power 2, like this. And then here minus power 1. That is 5 power minus 1, 5 power minus 2, like this. So D2, this is D0, D1, D2. So here D2 value is 1 into B is the 5 and power is 2, and then plus D1 is 2. See here. So D2 is the 1, and here base is 5 to 5 power 2 plus next digit 2 into 5 power 1 plus next digit 3 into 5 power 0 plus after the fractional part, decimal point, after the decimal point 4 into 5 power minus 1 plus 2 into 5 power minus 2. So this all we simplified, so we will get 38.88. That is decimal value, its equivalent decimal value 38.88. Base is 10. So any base to decimal conversion. So here we converted base 5 to a decimal conversion. Base 5 value is 123.42. Its equivalent decimal value is 38.88. Okay, likewise we can do any base to decimal conversion. So if it is not standard base, also we can perform like this. Okay. So next, binary to decimal conversion. So binary to decimal conversion. So what we discussed in the previous, so like this only, its position value, here the base is 2, base 0, 1, 2, and here minus 1, minus 2, base power minus 1, minus 2, like this. So this is the digit value, D2 is this value, and into B is here 2, that is 2 power 2 plus like this. So 1, 0, 1, so its position value base power 0, base power 1, base power 2. And then after the decimal point, so base power minus 1, base power minus 2. So 1 into 2 power 2 plus 0 into 2 power 1 plus 1 into 2 power 0 plus 2 into 2 power minus 1 plus 1 into 2 power minus 2. So 2 power minus 1 is nothing but the 1 by 2. The 2 power minus 2 is nothing but the 1 by 4. So likewise here, so we know the 2 power 0 is equal to 1 and 2 power 1 is 2 and 2 power 2 is 4. So this value is given. So for simple understanding. So 1 into 4, 4. Then this here is 0 and then 2 power 1 is 1, 1 into 1, 1. So 4 plus 1, 5. And then after decimal point, this is the after decimal point value, 1 by 2. So 1 by 2 is the 0.5 and 1 by 4 is 0.25. So here 0 means, so it won't come. So 0 into 0.5, so it becomes 0, and then 1 into 1 by 4, that is 0.25. That's why the 5.25 is its equivalent decimal value. So 101.01 binary value, so its equivalent decimal value is 5.25. So binary to decimal conversion. Next, octal to decimal conversion. So this is the given example. So first we need to write the given value, and we have to place the position value, that is base and its power position. So the power value is 0, 1, 2, and here the base is 8. So 8 power 0. So 8 power 0 means 1. So 8 power 1, 8. So 8 power 2, 64. And then after the decimal point, so 8 power minus 1, that is 1 by 8. 8 power minus 2, that is 1 by 8 power 2, that is 1 by 64. So all we did, so we get, so the 5 into base 8 power 2, that is 5 into 64 plus 1 into 8 plus 2 into 8 power 0, that is 1. And then 7 into 8 power minus 1 plus 4 into 8 power minus 2. So 330.9375 is the equivalent decimal number of this octal number system. 512.74 octal number system, its equivalent decimal number system is 330.9375. Next, hexadecimal to decimal conversion. So this is the given hexadecimal value 1E5.7A. So hexadecimal means, so it contains numbers and alphabets. So numbers is 0 to 9 and alphabets should be A to F, that is A, B, C, D, E, F. Up to F alphabets contains in the hexadecimal value. Okay. So 1E 5.7A. So its base is 16 power 0, 1A, 16 power 1, 16, 16 power 2, 256. And then after the decimal point, 16 power minus 1, 1 by 16, 16 power minus 2, 1 by 256. So we substitute these values like this in this formula. So 1 into 16 power 2 plus E is the 14. So we can't multiply E. So that's why it's here we are using its equivalent value. So E means 14. So 14 into 16 power 1 plus 5 into 16 power 0 plus next after in the decimal point 7 into 16 power minus 1, and then here A. So A we can't directly multiply. So its equivalent value is 10. So 10 into 16 power minus 2. And then after I do the all calculation, so we will get finally 485.4765625 is the decimal value of this hexadecimal. So got it? So 1E5.7A is the hexadecimal. Its equivalent decimal value is 485.4765625. Okay, next binary octal number system. That is binary to octal number system. So binary to octal number means, so octal means 8, that is 2 power 3. So 2 power 3, when we represent in the octal number is equal to binary value, so we need to represent in the 3 bits. So group of 3 bits. So see in the table. So this is the given octal number 0, 1, 2, 3, 4, 5, 6, 7. Octal number means so 8 numbers. So 0 to 7. It contains 0 to 7. So its equivalent binary value. So we need to represent in the 3 bits. So we have to represent 3 bits. 0 means 0, 0, 0. 1 means 0, 0, 1. And 0, 1, 0. 0, 1, 1. 1, 0, 0. 1, 0, 1 for 5 and 6. 1, 1, 0 for 7. 1, 1, 1, 1. Triple 1. Okay, so when we represent octal, the binary values, that is group of 3 bits. So keep it in mind. Okay, so this is the given binary numbers. So given binary numbers 10.01 is the given binary number. So I need to convert into octal. So octal means simply we have to do the, so in the binary values we have to do the 3 bits group of 3 bits. So from the decimal point, so here I will take this bits 3 bit as a one group, and then next 3 bit as a another one group. So here only 2 numbers are there, no problem. So the last bit will consider as a 0. And then similarly after the decimal point, so we need to group as 3 bits. So 3 binary bits. So 0, 1, here there are 2 bits are there. So another one bit will be considered as a 0. So this will be 3 bits like this. So 3 bits and then next 3 and then next 3. So you see the look up the table. So 110 means 6 here. So this value is 6. 110 means 6. And then here we will consider as a 0. 0, 1, 0. 0, 1, 0 means 2. And then here 0, 1. So third bit. So this will be considered as 0. So like we will consider as 0. So wherever finding empty space, so we will consider as a 0. And then 0, 1, 0 means, so 0, 1, 0 means 2. So like this 2 26.2. 26.2 is its equivalent octal number. So given binary values is equivalent by octal values 26.2. In the same way, so we will do octal to binary also. Okay, so next binary to hexadecimal. So hexadecimal means 16, that is 2 power 4. So we need to represent it as a 4 bit. Each hexa value is represented as 4 bits. You see, octal we have to represent in 3 bit, group of 3 bits. Here group of 4 bits. You keep it in mind. So like 0 to 9, then after 9 A, B, C, D, E, F. So F is 1, 1, 1, all 4 1. So you see the example. So 1, 0, 1, 1, 0.01 is the given binary value, and then here we need to group as 4 bits like this, and then remaining bit will be considered as 0, 0, 0, 0, 1, 0, 1, 1, 0. The after decimal point 0, 1, here the 2 bits only available, then another 2 bit will be considered as 0. So like 0, we will put 0. So here also we will put 3 zeros because there is only 1 bit is available, and then remaining bit will be considered as 0. So 16.4, that is 16.4 is its equivalent hexadecimal value. So okay. So intermediate conversion, octal to hexadecimal, that means, so octal to, first we need to convert binary. So binary, this is the given octal number. So its equivalent binary values. Octal means from octal to binary means what we need to do. So for 2 we have to write it in 3 bits, that is 0, 1, 2. For 6, 1, 1, 0, and then 2, 0, 1, 0. Okay, so here we converted octal to binary. Then after binary we need to convert hexadecimal. For hexadecimal we have to group 4 bit as a binary value. So a group of 4 bits, we need to do the 4 bit formation like this, 0, 1, 1, 0, and its equivalent hexa value we have to write here 16.4. So okay.